A dog lies asleep at the foot of a bed tonight, its paw twitching softly against the blanket. Its eyelids flutter, and beneath them, its eyes are moving, darting and searching, as though watching something unseen in the room. A soft whine escapes its throat in the quiet room. Then, just as quickly, it settles back into stillness. Could your dog actually be dreaming about you, right now, in this exact moment, while it sleeps beside you? We'd all like the honest answer to be yes, but science simply isn't willing to say that. Not yet.
To find out how close we can actually get to that answer, we first have to understand what a dream even is. Before asking what a dog dreams about, there's a more basic question worth settling. Does a dog's brain even sleep like ours does? The answer, recorded through modern polysomnography, sensors quietly reading brainwaves through the night, is yes, in structure, though not in rhythm. A dog moves through the exact same stages we do: wakefulness, drowsiness, non-REM sleep, and finally REM sleep. But where a human sleeps once and simply calls it a night, a dog's rest breaks into dozens of short cycles instead.
Each of those cycles lasts less than an hour, spread quietly across the day and night alike, again and again. Within non-REM sleep, the brain settles into slow, heavy delta waves, rolling steadily through the quiet, resting mind. Sleep spindles, brief bursts of rhythmic activity, are increasingly treated by scientists as a genuine signature of learning itself. Then REM arrives, and the brain wakes up, electrically speaking, even while the body stays completely still and silent. This is the sleep stage most closely associated, in every mammal studied so far, with the act of dreaming.
The architecture for a dream is clearly there. What fills that architecture is the far harder question still waiting to be answered. Answering that question means asking why, during this exact stage of sleep, the body goes completely still at all. Deep in the brainstem sits a small cluster of cells that during REM sleep does something genuinely remarkable. It sends a steady signal down the spine that switches off the body's entire ability to move at all. The mind runs freely. The muscles do not. A built-in brake, keeping the animal from acting out its own dream.
What happens when that brake fails is exactly where the evidence turns genuinely striking and impossible to ignore. In dogs recovering from tetanus, a toxin that interferes with exactly this signal, something extraordinary has been carefully recorded. Freed from paralysis, a sleeping dog will suddenly sit up and begin to move. Not randomly, but with clear purpose. Pointers have been recorded assuming a classic pointing stance, nose fixed steadily on something entirely invisible to us.
Dobermans have been recorded snarling at nothing at all, as though defending territory from an intruder no one else can see. These are coordinated, breed-specific behaviors, the very same motor patterns these dogs perform while fully awake and alert. We cannot honestly say whether this proves a rich inner story is unfolding or a rehearsed motor script firing without a mind. But the pattern itself, a body acting out its training uninvited in the dark, is hard evidence, however you choose to read it. If a body can act out a memory this clearly, can a brain replay one silently without ever moving at all?
The clearest evidence for this comes not from a dog at all, but from a rat in a laboratory. Researchers recorded individual brain cells inside a rat's hippocampus while it ran through a maze during the day. Each cell fired in a specific sequence, tracing the rat's exact path through that maze, step by step. Then, while the rat slept, those same cells fired again, in the same order, compressed neatly in time. It was as though the maze were running all over again, invisibly, inside a small, quietly sleeping skull.
This exact level of precision has never once been recorded inside a sleeping dog. At least not yet. But a dog's hippocampus runs on that same basic architecture, built from nearly identical neural machinery and wiring. The inference that dogs replay their day the same way isn't proof, but it's something very close to it. If dogs really do replay memories while they sleep, the very next question becomes genuinely unavoidable to ask now. Which memories, out of an entire day, matter enough to actually be replayed while the dog is sleeping? So, if a dog's brain replays the day, what exactly does it choose to keep and hold on to? This is where the story turns for the very first time toward you, specifically, and no one else at all. A dog's brain holds dedicated regions built specifically for recognizing human faces and voices, hardware remarkably specialized for people. Every single time your dog catches your familiar scent, something measurable happens deep inside its own reward circuitry. That same region lights up strongly around food, and in many dogs, the response to you has actually rivaled it. None of this proves you appear inside a dream, but it proves something almost as remarkable in its place. Among everything a dog's brain could possibly choose to hold on to, you are wired in as something genuinely valuable. What if your brain isn't the only one still listening, even long after every light in the house goes out? Researchers studying brainwave responses in lightly sleeping dogs found that the auditory system never fully closes for the night. Human voices and dog vocalizations still register quite differently inside a sleeping brain, even deep in the dark. So does tone. A sleeping dog's brain clearly responds differently to a warm voice than it does to a flat one. This doesn't prove the dog is actually dreaming about that voice or even consciously aware of hearing it at all. What it shows instead is a gate left slightly open, social sound still reaching in, even past the edge of sleep. Whatever machinery a dog uses to recognize the people in its life, it seems, doesn't go fully dark when the dog does. Does who a dog sleeps near actually change how deeply or how restlessly that dog manages to sleep at night? Researchers comparing dogs resting in unfamiliar settings, with and without an owner present, found a genuinely clear pattern. With the owner nearby, dogs fell asleep noticeably faster and spent more time in deep, restorative non-REM sleep overall. Without the owner present, that pattern clearly shifted. Sleep grew lighter, and REM sleep noticeably increased instead. One cautious interpretation offered by the researchers is that this REM increase reflects the brain working through the stress of separation. It's a reasonable enough read, though certainly not a fully confirmed one, by the researchers who first observed this pattern. What's most measurable is only this: your simple presence changes the actual shape of your dog's sleep every single time. What that reshaped sleep actually contains, honestly, remains a careful guess. No instrument has yet been able to answer. Every piece of this evidence has a real, honest limit, and it's worth sitting with that plainly for a moment. A brain reacting to your face, your voice, or your scent isn't quite the same as forming a full narrative dream. It's also worth quietly noting that dogs spend measurably less time in REM sleep than wolves generally do. One working hypothesis holds that a safe home, free of any real threat, may simply need less of that sleep stage. Some researchers call the leap from basic mechanism to owner-specific dreaming a scientifically reasonable, if careful, inference to make. Others call it, far more bluntly, anthropomorphism, simply wearing a lab coat, dressed up in careful scientific language. Both of these descriptions are being offered right now by serious people about the exact same set of facts. Hold on to that tension for a moment. Don't resolve it faster or more comfortably than the evidence itself actually allows. We still don't genuinely know what a dog sees behind its closed eyes, not with any real certainty at all. We may never know for certain, not because science has failed here, but because the question asks for something fundamentally unreachable. No brain scan has ever handed over another mind's private experience from the inside
In its own honest words, science cannot tell us exactly who appears inside a dog's dreams, not with any real verifiable certainty at all. But it can tell us whose face, whose voice, whose scent, and whose memory fill nearly every corner of its waking world. Maybe the dog at your feet tonight is simply chasing a scent it caught earlier that very morning. Maybe it's simply running through a wide field that only exists somewhere deep inside its own private memory. Or maybe, in whatever strange and private way a dog actually gets to have one, it is quietly dreaming. Dreaming of the one face it spent thousands of years slowly evolving, patiently, to never once stop looking for. Yours.